1997. Deep Blue beats Kasparov at chess. 2016. AlphaGo beats Lee Sedol. 2019. OpenAI 5 beats a Dota world champion. In every one of those cases, we had an autonomous system that took actions in a loop, used tools, and got measured on the task. By our own definition from last video, those were agents. So why is nobody calling Deep Blue an AI agent? Because the substrate matters. When we say AI agent in 2026, we mean a system built on top of a large language model, not a search tree, not a reinforcement learning policy, not a rules engine. Today, the whole video is one question. What does an LLM have that those other substrates do not? That made it the only viable engine for a modern agent? 3 properties. That is the answer. I am Ani. Let us get into it. Video 1 ended with a definition and a 5-station loop. Perceive, reason, plan, act, observe, and I promised that from here, we would zoom into each piece of that machinery until you could build one yourself. That is the plan for the rest of Lecture 1. Today we are inside the box marked modal, the engine that sits at the very bottom of the stack and does the thinking. Now the puzzle for this video. Every autonomous system before ChatGPT was handcrafted for its domain. Deep Blue could only play chess. AlphaGo could only play Go. Even the fanciest ones were domain locked. But Claude Code can write software and book flights and analyze a spreadsheet and draft an email with the same underlying model. Nobody rewired the network between tasks. What kind of substrate lets you do that? Answer: one that reads instructions in English. That is the whole shift. Today's 3 beats. First, the 3 properties an LLM has that made it the only workable substrate for a modern agent. Second, a 2026 lap through the actual model families: Claude 5, GPT-5, Gemini 3, Llama 4, Qwen, what each does slightly differently. Third, the honest limits of the substrate, where the LLM does not do what people assume it does. Property 1, INCONTEXT learning. Brown and colleagues at OpenAI named this in the GPT-3 paper, 2020. You put a handful of examples in the prompt. Say, 3 examples of a customer email and a good reply. And the model, without any weight updates, without any fine-tuning, just learns the pattern from those 3 examples and applies it to the 4th. Nothing before an LLM could do that. A decision tree cannot. An RL policy cannot. Every previous substrate needed retraining to learn a new task. LLMs learn in the prompt. That property alone is why agents can be generalists. Property 2, NATURALLAN, GUAGE reasoning, also called chain of thought. Wei and colleagues at Google, 2022. Give the model space to think out loud in English before answering, and its accuracy on hard problems jumps, not marginally, sometimes doubles. This matters for agents because the loop's reason station needs an engine that can actually think through a plan. LLMs can do that in prose. Decision trees cannot reason about a problem they were not trained on. RL policies cannot explain themselves. The LLM writes first, I should grep for settings, then I should read the theme file, then edit the CSS in English before doing anything. That is what the loop's reason step actually is. Property 3, TOOLCALL generation. This is the one people forget. Modern LLMs can emit structured output. You give them a JSON schema for a tool, say a search web function, and they will produce a valid JSON block calling that function with correctly typed arguments. Not English about calling the function. An actual JSON payload the framework can execute. OpenAI shipped this in June 2023. Anthropic in November of the same year. Now every serious provider supports it. This is the property that makes the ACD station of the loop possible. Without structured output, the model can only produce prose, and prose cannot invoke a function. Beat 2. The 2026 Model Lab. Claude 5. Anthropic's family. Opus 4.8 at the top, Sonnet 5 in the middle, Haiku 4.5 at the small end. Claude is known for tool use reliability and long context reasoning. When Claude Code was released, it was built on Claude because the model would emit tool calls that actually worked 40 times in a row without going off the rails. All 3 properties dialed hard on property 3. GPT-5, OpenAI, the successor to the GPT-4o line. known for the widest tooling ecosystem. Operator, ChatGPT agents, the Assistance API, Code Interpreter. If you want an agent that connects to 50 existing enterprise integrations tomorrow morning, you probably start on GPT-5. Gemini 3, Google DeepMind, the multimodal specialist, best at video, screenshots, and huge context windows. Powers a lot of the browser use and computer use demos you have seen this year. Same 3 properties, different sweet spot. And the open weight side, Llama 4 from Meta, Qwen from Alibaba, both catching up on tool use reliability, both preferred when you have to run the model yourself. Privacy reasons, cost reasons, air-gapped reasons. In 2026, the honest gap between the top closed model and the top open model is roughly 9 months. If your agent has to run entirely on your infrastructure, you use one of these. Same 3 properties, slightly noisier tool calls, improving quickly. Beat 3. The honest limits of the substrate. Number 1. In-context learning is not stable learning. The model learns your 3 examples for this one call and then forgets. Every new session, you repaste your examples, or you fine-tune. There is no accumulation. This is the whole reason we spend a full video on memory later. Number 2. Natural language reasoning is not proof. The model writes reasoning that looks logical. Sometimes that reasoning is wrong. Sometimes the reasoning is right, but the answer contradicts it. Chain of thought is a giant improvement over direct answers, but it is not a theorem prover. This matters when your agent is booking flights with real money. Number 3. Tool call generation can hallucinate the tool. The model can emit a beautifully typed JSON call to a function that does not exist, or with a parameter the schema does not accept, or with the right shape but wrong semantics. Frameworks catch the syntax errors. They do not catch the semantic ones. This is exactly why real agents run in a loop with validation, retries, and guardrails, not one shot, which is our story for the next 4 videos. Loop mechanics, tool schemas, memory, the full stack. 3 takeaways before the quiz. 1. An LLM is the substrate for a modern agent because of 3 properties nothing else has all of. In-context learning, natural language reasoning, structured tool call generation. Memorize those 3. They are the reason your agent is a general-purpose engine, and Deep Blue was a chess-only engine. 2. In 2026, the model options are Claude 5, GPT-5, Gemini 3, Llama 4, Qwen. Same 3 properties, different sweet spots, tool reliability, ecosystem, multimodal, or self-hostable. 3. The substrate is not magic. It forgets between sessions, its reasoning is not proof, and it can hallucinate tools. Every other layer of the stack exists to compensate for exactly those 3 limits. Quiz 1. Which 3 properties of an LLM make it a viable substrate for a modern AI agent? A speed, cost, and open weights. B. In-context learning, natural language reasoning, and structured tool call generation. C. Multimodal input, RAG, and fine-tuning. Or D. Attention, tokenization, and softmax. B. In-context learning lets the agent generalize without retraining. Natural language reasoning powers the reason step of the loop. Tool call generation powers the ACT step. Drop any one of those 3 and the substrate stops working for agents. This exact framing comes back in the V6 recap. Keep it filed. Quiz 2. Why is Deep Blue technically an autonomous agent but not what we mean by AI agent in 2026? A Deep Blue was too slow. B. Deep Blue was handcrafted for chess and could not generalize. A modern agent runs on a general-purpose LLM substrate that reads instructions in English. C. Deep Blue was not on the internet. Or D. Deep Blue was closed source. B. The substrate is the shift. Deep Blue was domain-locked. Every one of its capabilities was hand-programmed for chess. Claude 5 can code, book flights, and analyze a spreadsheet without a single wire being rewired. The engine is general purpose, and its instruction language is English. Quiz 3. Which of the following is an honest limit of the LLM substrate that other layers in the agent stack exist to compensate for? A. LLMs cannot use JSON. B. In-context learning forgets between sessions, reasoning is not proof, and tool call generation can hallucinate the tool. C. LLMs can only speak English. Or D. LLMs cannot be deployed on GPUs. B. Those three limits are exactly why we have the other four layers. Memory covers forgetting. The loop plus guardrails cover bad reasoning. Tool schema validation catches hallucinated calls. Every future video in this lecture is answering one of those three limits. Back to the puzzle. Do AI agents actually reason? After 2 videos, we know the substrate reasons in natural language, and we know that natural language reasoning is not proof. It is impressive, useful, and provably wrong sometimes. That is what we are building on top of, not something else. 2 down, 28 to go. Next time, the loop. Not the 5-station overview from video 1, the actual paper that named the pattern. Yao and colleagues, 2022. React, reasoning plus acting, interleaved. Still the reference architecture every real agent runs. We look at what the paper actually said, why the interleaving works, and how Claude code runs a modern version of it 40 times per pull request. Hit subscribe.